In this set of practice questions, we are going to solve some questions related to inequalities. We're going to look at a graph of an inequality and circles. So looking at number 1, if x and y are real numbers such that x is greater than 0 and y is less than 0, then which of the following inequalities must be true? So if they tell us that x is greater than 0, we know x is positive, y is less than 0, y is negative. So let's just begin. This is a which question. So what that means is we have to look through our answer choices to determine which must be true. It's not like we can just work the problem and then match up our answer. We have to evaluate these. So when I'm looking at A through E, each one of them could have their own complexities in it. So let's just begin with a choice. And what it says is x over y is greater than 0. Well, when we look at our signs, we know if it says it's greater than 0, it must be positive. But what did we already say about x over y? It is a positive over a negative, which would give us a negative, and that would be less than 0. So answer choice A is out. Now let's look at B. It says that the absolute value of x squared is greater than the absolute value of y. Well, we've already said that x is positive and y is negative. When we take the absolute values of those numbers, we're always going to get a positive. A positive absolute value of x, we're going to get a positive. Squaring that, we don't know that it's necessarily, though, greater than the absolute value of y because we don't know the values of x and y. X could be greater than y, and then when we square it, it would be greater. But x could be less than y, and when you square it, we still don't know. So we can't say for sure. So B will not necessarily always be true because we can find a case where it would not be. Now let's take a look at C. What I want to look at here is notice that we're doing the same operations to both sides. And so if we do something to one side and we do it to the other, it's almost like they can cancel out. I can almost say I'm subtracting 4 from here, but I'm also doing it there. So I can almost ignore those for now. And then I'm also dividing x by 2 and I'm dividing y by 2. So I'm going to take that away. And I'm left with, is x greater than y in all cases? Well, what's happening here? X was going to be a positive number. Y is a negative number. So X will always be greater than Y because a positive is always greater than a negative. Even if when I subtract by 4 on this positive, let's say X was 3, and I subtract 4 and make it a negative, Y was already negative, and I'm going to make it more negative down by 4, so it doesn't matter. So in all cases, C is going to be the correct answer. Now, we kind of work this out by thinking about the theory, looking at in general what these values would be, but you could always plug in values for x and y based on what we know from the if statement in the question, and then try each one of these operations. Let's take a look at number 2. Which of the following is equivalent to the inequality 2x minus 4 is greater than 4x plus 12? When we look at our answer choices, that may give you a little clue on what we need to do. It looks like we've put the x on the left-hand side and anything else on the right-hand side. So let's try to work that out here. We have 2x minus 4 greater than 4x plus 12. Let's subtract 4x from both sides, and we get a negative 2x minus 4 is greater than 12. Add 4 to both sides, and we get negative 2x is greater than 16. We're going to divide through by negative 2. And remember, when we do that, we have to flip the sign because we're dividing through by a negative, and we get x is less than negative 8. And that is answer choice F. Number 3 says one of the following inequalities is graphed below in the standard xy coordinate plane. Which one? So we're going to look at our graph, and the first thing we want to look at, and if we were drawing this we would look at our boundary line, and that is this right here. One thing I noticed, it is a solid line, so it should be some kind of either greater than or less than, but an equal. And in all cases of our answer choices, we have equal included, so that is there. And so if we could determine this line, our boundary line, we're almost there. So when I'm looking at this, one thing I want to pay attention to on my graph, this is 10. So each line on here, there are 5 lines up to 10, so each one must be 2, 4, 6, 8, 10. So we've got each line is equal to 2. I want to look at where it crosses the y-axis, which is right here at y equals 2. So I need to look, if I was just graphing this line, I don't know what my slope is yet, but I do know that my y-intercept is 2. Now we can determine our slope by starting with this point 0, 2, and then let's go to another point that we know of. This point right here is the point -2, 0. So to get from 0, 2 to -2, 0, I went down 2, back 2. So that was a -2 over -2, which is equal to a +1. And we know the slope is positive because it's increasing from left to right. So that would give us a slope of 1x plus 2, or just x plus 2. So we're looking at, this is our boundary line. So 2x plus 2 is not the same thing. There's another 2x plus 2. We have x plus 2, which is either C or D. E is out as well. Okay, so now we just need to know, is it greater than that or less than that? The more times you look at this problem, you will be able to tell that the shaded region is below the boundary line, right? So you will look at the shaded region and see that y is less than or equal to the x plus 2. That is going to be answer choice D. But we can always plug in a test point. And like I told you in the review slide, I like to point 0, 0, wherever that is. And right here we see it is in the shaded region. So if this is represented by the shaded region, whatever the sign is, that's what it would be. So we're plugging in 0 for x and 0 for y. So we have 0. We're not sure what goes in here. We're going to plug in 0 for x. So we have 0 plus 2. So basically we have the expression 0 to 2 is less than. That corresponds to y less than or equal to x plus 2. Again, answer choice D. Looking at number 4, which of the following is an equation of the circle shown below? As a reminder, our standard equation for a circle is x minus h squared plus y minus k squared equals r squared, the radius squared. And our h and k is our center. In our situation here, our center is 0, 0, so our h and k is 0, 0. That will cancel out to x squared plus y squared. And our radius, we go from 0 to, let's see, we've got 1, 2, 3, 4, 5 in between the 10 and 20. So that means every unit should be 2. It should be 2 units. And it looks like we're in the half between 12, 14, 16, between 16 and 18. So that's going to be 17 as our R value, 17 squared. So do we have anything that looks like that? X plus y squared equals 17 squared. That is K. Answer choice K gives us the equation of this circle. Number 5, in the standard XY coordinate plane, the center of a circle lies on the x-axis at x equals -3. If the circle is tangent to the y-axis, which of the following is an equation of the circle? So let's see what they're talking about here. We have our XY coordinate plane, and it says the center lies on the x-axis. We're talking about here the x-axis at x equals -3. So it looks like our center is at the point -3, 0. This is our HK. And it also says the circle is tangent to the y-axis. So tangent means it touches at one place, and here's our y-axis. So I have a feeling our circle is going to tangent right there. And so we have right here a radius of 3. R is equal to 3. So when we use our standard formula, x minus h squared plus y minus k squared equals r squared, we plug in an hk of negative 3, 0. Now this is where our minus signs come into play. So when we have a minus h here, a minus 3 gives us a x plus 3 squared, plus a 0 for k just gives us a y squared. That cancels out. And we said our r was equal to 3 squared, which is 9. We can simplify x plus 3 squared plus y squared equals 9. And that should be equivalent to answer choice A.